A single drop of water contains a tiny world where a knife's cutting edge can unleash a maelstrom of microscopic mayhem. Imagine a world where the cutting edge of a knife is not just sharp, but also a catalyst for a tiny tornado of motion. This phenomenon occurs when the knife's edge interacts with the water molecules in a drop, creating a vortex of whirlpools. The whirlpools are so intense that they can trap tiny particles like dust and pollen, making the water appear cloudy. But that's not the strangest part. The whirlpools can also be used to separate particles of different sizes and densities. For centuries, scientists have been studying the behavior of fluids and the interactions between different materials. One of the most fascinating aspects of fluid dynamics is the way in which tiny perturbations can have a major impact on the behavior of the system. In the case of the knife cutting through water, the edge creates a series of tiny waves that propagate through the fluid. These waves can be thought of as a kind of microscopic tsunami that can have a significant impact on the surrounding environment. The speed and amplitude of the waves depend on the properties of the knife and the water, as well as the angle and force of the cut. But wait until you hear what happens when the knife is made of a special material that can slice through the water with minimal resistance. The result is a phenomenon known as hydrodynamic slip. The knife appears to be cutting through the water with ease. The science behind hydrodynamic slip is complex, but it essentially involves the creation of a thin layer of gas between the knife and the water. This layer reduces the friction between the two materials, allowing the knife to move through the water with minimal resistance. It's like trying to cut through a dense fog. The knife needs to penetrate the gas layer to make progress. And then something unexpected happens. The knife starts to move at an incredible speed, leaving a trail of bubbles behind it. This is known as the cavitation effect. The knife creates a series of tiny vacuum bubbles as it moves through the water. The cavitation effect is so powerful that it can be used to clean surfaces, break up blockages, and even create complex shapes and patterns. Scientists have been studying the cavitation effect for decades, but it remains one of the most fascinating and poorly understood phenomena in fluid dynamics. The main challenge in understanding the cavitation effect is the sheer complexity of the system. Many different factors interact to create the phenomenon. But by studying the behavior of the knife and the water, scientists hope to unlock the secrets of the cavitation effect and develop new technologies based on it. The potential applications of the cavitation effect are vast, from medicine to materials science. The possibilities are endless. Imagine being able to create complex shapes and patterns with ease, using a knife as the tool. It's a prospect that is both exciting and daunting. The potential for innovation and discovery is huge, but the challenges are significant. And yet, scientists remain optimistic, driven by the promise of new breakthroughs and discoveries. The journey of discovery is a long and winding one, but the rewards are well worth the effort. So, what does this mean for us? How can we harness the power of the cavitation effect to create new technologies and innovations? The answer lies in the science. By understanding the complex interactions between the knife and the water, we can unlock the secrets of the cavitation effect. It's a challenge that requires patience, persistence, and a passion for discovery, but the rewards are well worth it. The potential for innovation and discovery is huge, and the journey is just beginning. So, if you found this fascinating, subscribe for more incredible stories like this. Want more mind-blowing facts? Hit subscribe and join our journey of discovery. Thanks for watching. Don't forget to subscribe and hit the like button.